Hello students, welcome to part 2 of the chapter Some Basic Concepts of Chemistry. In this part we are going to see about mole concept, what a mole concept is, and about molar mass. So in our daily life we come across several systems that is used to quantify counting. So for example, one such example is a dozen of apple. So a dozen of apple counts for 12 apples. Similarly, another system is gross. Gross is a set of apple that contains 144 apples. So these are the systems that is used to simplify the counting, or you can say quantify counting. So these systems cannot be used to quantify or simplify the counting in case of small atoms and molecules, because if we want to simplify, then this 12 atoms or 144 atoms will be too small to quantify them. So in order to quantify the counting of atoms and molecules, we have introduced a new quantity called mole. So mole is nothing but very much similar to the system used to count bigger items like 12 apples and 144 apples. Here we use to count smaller atoms and molecules using mole. So mole is a quantity. So in the case of atoms and molecules, a new quantity was introduced and it is called mole. Question is, how much is a mole? So we know dozen is 12 and a gross is 144, and how much is a mole? So for that we are doing a small calculation. We know that 1 AMU is 1.6605 for 10 raised to minus 24. So this we have learned in the last part. So what we have learned is 1.66 into 10 raised to minus 24. To make it a little more exact, I am taking the exact value of 1 AMU here. 1.66054 into 10 raised to minus 24 grams. Now how much AMU will be there? So 1 AMU means this. How much AMU will be there in 1 gram? How to get this? You just divide 1 gram with 1 AMU. So to make it a little bit more clear, so I have said that or in the previous part we have learned that this 1 AMU is approximately the mass of a proton. Now proton, its mass is approximately equal to 1 AMU. So if I write that, so I can say that this is mass of 1 proton. Clear? This is mass of 1 proton. And so if I am taking 1 gram of proton, 1 gram of proton, how many protons will be there? You can just rephrase this question into that. So I know that mass of 1 proton is equal to 1.6605 for 10 raised to minus 24 grams, and I have 1 gram of proton with me. I just want to know how much protons will be there from these two measurements. Total mass is 1 gram and one proton weighs this. What do you have to do? You have to do is like 1 gram divided by mass of 1 proton. So you will get the number. That is 6.022 into 10 raised to 23. So this is now a standard number. Why is it standard? Because we know that this is a basic unit of all matter. Clear? So since this is the basic unit, now which is difficult to measure because extremely small value, whereas 1 gram now I can measure. So now what I did was 1 gram I divided with AMU, and immediately you get a number. Now this is something that I can use as a standard. So this number is now known as a mole. So a mole is nothing but a number. And how big is this number? You can see it here. So if I am converting this notation into a original or a real number, it will be something like this, such a huge number. So such a huge number is not practical in the case of real world, Like if you are counting apples, such a measurement is not possible. So in the case of apple, you can use dozen or gross, but you can't use this. But in the case of atoms, you can't use dozen or gross. For atoms, if you are using the systems like this, like such a big number, then you can weigh the things, like 1 gram is having this much. I hope it's clear. So in 1 gram there are this much, or this much AMU. How did you get it? 1 gram divided by the mass of 1 AMU. So you will get this number, and this number is now used as a quantity to count number of particles. Clear? So we have that number of mole, that is 6.022 into 10 raised to 23. This number is also called Avogadro constant, called to honor Avogadro, who was behind finding this number, or Avogadro number. Both are represented using this abbreviation, that is N subscript higher case a, okay, uppercase A. So this number is called a mole, or it can be also called as Avogadro constant or Avogadro number. Okay, so what is mole? Mole is used as a quantity to quantify elementary particles. How to define it? A mole is defined as anything that contains 6.022 into 10 raised to 23 particles. And what is its unit? Its unit is MOL. So we have learned in the previous part that unit of mass is kilogram. So mass was a quantity, like that mole is a quantity, and unit of mass was kilogram, like that unit of this quantity mole is MOL. What's the difference between? The difference is only that E is absent here. So whenever you are using this unit, use only these three alphabets, or either you can say that it is the number of quantities MOLE, or you can use plural form if you are using the whole name. But once when you are using for calculations and all, when you are using, you should use only this unit, that is MOL. Okay, so a mole of particles. Now we know what a mole is, right? So if I'm saying what is a mole of H2, a mole of H2 means you simply replace this mole with that number, 6.022 into 10 raised to 23 H2 molecules. Or another way around, if you have this much number, I can say that it is a mole of H2. 6.022 into 10 raised to 20, it's a mole of H2. Or if it is anything else, like if it is 1 mole of water, that means 6.022 into 10 raised to 23 water molecules. Or if it is 1 mole of oxygen molecule, O2 molecule, then you can say that it is 6.022 into 10 raised to 23 molecules. Then what about 2 mole? 2 mole means twice this number. What about 3 mole? 3 mole means thrice this number. Clear? What about a fraction? Let's look at an example. How much molecules of H2O does 0.5 mole? So what is 0.5 mole of H2O? That's the question. If 1 mole is this much, how to get number of molecules in 0.5 mole? You just multiply this with that 0.5 mole, like this. Number of molecules of H2O in 1 mole of H2O is equal to, this is about 1 mole. So it is 6.0 10 raised to 23. What about 0.5 mole? 0.5 mole, if you want to get it, you multiply this value with whatever they have asked, that is 0.5 mole. So you will get it as 3.011 into 10 raised to 23. So this is how you can express the number. So mole is a quantity that is used to express the number. Clear? So next, how many oxygen atoms are there in 2 mole of CH3COH? How many oxygen atoms are there in 2 mole of CH3COH? If you look into one molecule, you will see that there are 2 oxygen atoms, isn't it? Number of oxygen atoms in one molecule, you have CH3COH, that means 2 atoms of oxygen. So what if in one molecule it is 2 atoms, so what about 1 mole? 1 mole of CH3COH, it will be 2 mole of oxygen atoms. So in 1 mole there are 2 moles of oxygen atoms. So what about whatever they have asked, that is 2 mole. What about 2 mole? 2 mole is equal to 2 into 2 is equal to 4 mole atoms. So they have asked for how many. That means that you cannot express it in mole, you have to make it into a real number. So you just substitute this mole with its number, that is 6.022 into 10 raised to 23. So 4 into 6.0 10 raised to 23, you will get the number of atoms in 2 mole of CH3COH. So the solution is 24. If you multiply this 24, if you are moving one decimal place to the left, then 2.408 into 10 raised to 24. Clear, I guess. Next, calculate the number of atoms and molecules present in 3 moles of H2SO4. Calculate the number of atoms and molecules present in 3 moles of H2SO4. They are asking for number of atoms. That means that you have to go for all atoms. They are not asking for a specific atom, but for a number of atoms. That means if you are looking into sulfuric acid, you will see that there are 2 hydrogen, 1 sulfur and 4 oxygen atoms. So making them to total of 7 atoms in one molecule. So what about 1 mole? 1 mole will have 7 mole of atoms. If one molecule is having 7 atoms, then 1 mole will be having 7 mole of atoms. So what about 3 mole? You just multiply it with 3. 7 into 3, that is equal to 21 mole. So they have asked for number. So you should have a real number. So I should substitute for this mole here. 21 into 6.02 is 23. When you multiply this, you will get 126. So if you move the decimal place onto the left, you just increase the power of 10 here by 2. Since you have moved decimal place 2 to the left, you increase that number here to compensate. That is 23 to 25. Clear? So number of molecules present in 1 mole of H2SO4. 1 mole of H2SO4. Next question is about molecules. So in molecule, in this entire thing, there is only one type of molecule, that is H2SO4. So in 1 mole it is 1 into 6.02 So 3 moles means just multiply it with 3. 3 into 6.022 into 10 raised to 23, that is 1.81 into 10 raised to 24. Actually it is 18. You will move one decimal place to the left, then it is 1.81. To compensate that, you just raise that exponent of 10. Okay, so that's how to calculate the number of atoms and number of molecules in given mole of a compound. So now let's try to recollect something. We have seen that how to calculate the number of AMUs in 1 gram, isn't it? Initially we saw to find out the value of mole. So 1 gram divided by mass of 1 AMU is equal to 6. We got this value. So if you are rearranging this in a way that 1.6 this mass into number, I will get 1 gram per mole. So this mass here represents 1 unit. If you are multiplying this 1 unit into our Avogadro number, or our number that is representing mole, this Avogadro number, if you are multiplying with that, what you are getting is 1g. So what's the connection between this value and this value? It's very simple. So if you are multiplying any u with an Avogadro number, you are supposed to get the same magnitude, but its unit is gram per mole. So its magnitude will be in gram. I hope you got it. So this value represents 1u. So when I multiplied this value with Avogadro number, I will get 1 gram, isn't it? So this value means it is 1u. So when I multiplied this value with this, that means that 1u will now turn into the same the value with the same magnitude, but the unit is gram. Since it is of 1 mole, we just write it like per mole. Clear? I'm showing it again here. Mass of a mole of a substance. 1 u into 6.010⁻23 is 1 gram per mole. This is what we saw earlier slide. 1 u, if you multiply it with the Avogadro number, you will get 1 gram per mole. So I am not directly multiplying 1 u. What I am doing is I am taking the value of 1 u here. Similarly, if you are multiplying 12u, what you will get here? If I multiplied 1u, then I get 1 gram. That means if I multiply 12u, 12u means whatever unit I had here, it is 12 times here, isn't it? That 1.66 into 10 raised to minus 24. Here it is into 12. So what we will get here? You will get 12 grams. Clear? Similarly, whatever value I take here, 16u into a mole will be equal to 16 gram. So if you are substituting that value, you will see that. Clear? So 18u, again 18u multiply, then you will get 18 gram. So what is this? This is what you know, that it's a mass of one hydrogen atom. And what is this? This is the mass of 1 mole of hydrogen atom. So that's the difference. And what is this 12u? Which atom has this mass? It is carbon atom. So one carbon atom is multiplied with a mole. That means that this is the mass of 1 mole of carbon atoms, isn't it? This represents a mole. If you are multiplying a mass with that number, that means that now it is the mass of 1 mole of atom. And what is its mass? It is 12 gram. So 1 mole of carbon atoms. Again, in case of hydrogen, oxygen, here it is oxygen 16u, and if you multiply, that means that whatever I got is the mass of 1 mole of oxygen atoms. Next, if this is for water molecule. Now if I multiply with a mole, I will get 1 mole of water molecule. So what I can say in generalize, how can I generalize it? This is atomic mass. Maybe it is it's atomic mass, or in this case it is molecular mass. If you multiply that mass with 1 mole, you will get a value here. And what does this value stand for? It stands for 1 mole. So since it is 1 mole, you can call it as molar mass. What's it? It's the mass of a mole of substance. So you can call it as molar mass. So what is the connection between atomic mass and molar mass? It's very simple. You will have a mass in U, unified mass or atomic mass unit. You just express it in grams. Then it will be its molar mass. That means it contains 1 mole of that substance. In atomic mass, you will have only 1 particle, whereas in molar mass, you will have 1 mole of particle, and the difference between them is their unit. Here it is unified mass, here it is gram per mole. So that's the difference. Clear, I guess. Next, we have seen molar mass. What is molar mass? Mass of a mole of a substance is called molar mass. Clear? Then molar mass of a substance is obtained. How it is obtained? By expressing its atomic mass unit in grams. So for all the substance, it will have its atomic mass unit, that is mass of an atom or a molecule. Clear? If you express that mass of an atom or a molecule in grams, then it is called molar mass. What does molar mass stands for? It's the mass of 1 mole of substance. Clear? So unit of molar mass is gram per mole. It's gram of a mole. Clear? You can write it like gram mole raised to minus 1. When it moves to numerator, it becomes mole raised to minus 1. I hope it's clear. Once again, let's try to understand this. Atomic mass means, atomic mass, I will write it down, AMU is of 1 particle. AMU is of 1 particle, whereas molar mass is of 1 mole particle. So AMU is of 1 particle, whereas this is of 1 mole of particles. 1 mole of particles. Clear? So that's the difference between AMU and molarity. And if you, so unit of molar mass is gram per mole. As each compound has a unique AMU, each compound has a unique molar mass. As we know that AMU, when expressed in gram, is the molar mass. So since we have learned in the last part, each atom and each compound have a unique AMU. So that means that each substance or each compound has a unique molar mass. So from molar mass, it is able to identify, we are able to identify a compound. But there are exceptions. For example, isobars have the same molar mass because they have the same atomic mass unit. There are exceptions, but in most cases, if they are not isobars, you can easily identify the compound from its molar mass. Now, calculate the molar mass of CH3 COOH. How to calculate it? As we know, molar mass is nothing but its atomic mass unit expressed in grams. So, molecular mass is equal to 2 into 12. First, we have to find out the molecular mass. So, for that, we are taking the atomic mass. You are summing up the atomic masses of all the atoms. So, when you sum up, you will get 60U. So, what is the molar mass then? Molar mass is nothing but expressing atomic mass units in grams. So it is 60 gram per mole. Molar mass of acetic acid is 60 gram per mole. Clear? Next, we are going to see the equation connecting mass, molar mass and number of moles. So in order to get to this equation, we will look into a simple calculation. There are 10 moles of a substance. So 10 moles means 10 into 6.022 into 10 raised to 23 particles of a substance X. Okay, molar mass of the substance. So molar mass means what? It's the mass of 1 mole of substance. Molar mass is given as 60 gram per mole. I need to calculate. They have provided 10 moles. I need to calculate the mass of X in the container. So they have mentioned that there are 10 moles of substance and each mole weighs 60 gram. So each mole weighs 60 gram and there are 10 mole of substance. So what is the mass of X in the container? This is what we are going to see. So mass of 1 mole is its molar mass, that is 60 gram. And number of moles of X in the container is equal to 10 moles. So you just simply multiply that. So you have mass of 1 mole and you have 10 moles. So mass of 1 mole into 10, which will be equal to 600 grams. Okay, so how did we get this? What is this? This is called molar mass, isn't it? So this is molar mass, and what is this? This is number of moles. So you can see the abbreviations, like molar mass is represented as capital M and number of moles is represented as N. So if you multiply, you can see it from here. If you multiply molar mass with mass, you will get the total mass of the compound. So mass of the substance W in the container is equal to molar mass capital M into number of moles small n. So you can write it like this: W is equal to M into N. To rearrange that, if you are rearranging the equation, so we have the equation that we got from the previous slide and we are rearranging it like this: N is equal to, bringing M to this side, W divided by M. So this is one of the famous equation that need to be applied in almost all the chapters and all the parts of chemistry. So if you want to find out the number of moles, it's easy. Just find how many mass is there, how much mass is there, then divide it with the molar mass of the substance. You will get the number of moles that is with you. Okay. So based on this equation, we are going to see few calculations. Calculate the mass of 10 mole of acetic acid. So I have the number of moles. I have the formula of the compound, that is acetic acid. I need to calculate the mass. So what is it? We have the formula N is equal to W by M, or what they have asked is mass. So W is equal to M into N. By rearranging this equation, you will get that N is given 10. And what is the molar mass of acetic acid? You just calculate the molecular mass. You just add up all the atomic masses present in it, then convert that into gram per mole. So you will get the molar mass as we have said earlier. So C, we have 2C, that is 12 into 2, 24. We have 4H, 24 plus 4, 28. We have 2 O's, that is 32. 28 plus 32 is equal to 60. So you'll get 60 gram per mole is the molar mass of acetic acid. You just substitute these values into this equation. So when substituting 60 into 10, that is equal to 600 grams. So mass of acetic acid. 10 moles of acetic acid is 600 grams. Now calculate the number of moles of sulphuric acid present in 78 gram of sulphuric acid. So what they are asking is to find number of moles. The mass is given, that is 78 gram, and also from its molecular formula. What's the molecular formula of sulphuric acid? Sulphuric acid molecular formula is H2SO4. You can calculate the molar mass. So molar mass is 2 of hydrogen atoms, sulfur 32, and 16 into 4, that is 64. You will get 98 gram per mole is the molar mass. So first you will get 98 U, because you are calculating the molecular mass first, then you are converting that into molar mass. If you are expressing that molecular mass in gram per mole, then it is its molar mass. So you have the mass, you have molar mass here. You just substitute them, you will get the number of moles, and it is 0.796 moles. To the next calculation, calculate the number of molecules. So you have to calculate number of molecules present in 1 kilogram of sugar. So they have provided with the mass, and they have also given you the molecule. You have to do it. So what is the molecular formula of sugar? That is sucrose, that is C12H22O11. So if you find how many, 12 into 12 is 144, 22, 11 into 16 is 176. You add them up, you will get 342 U, and if it is expressed in gram per mole, then it is its molar mass. So we have got molar mass. Next is mass. Since this is in gram, this has to be in gram. So you convert 1 kilogram into gram, that is 1000 grams. So once you got this, you substitute them in this formula. 1000 for the mass and 342 for molar mass. Solve it, you will get 2.924 moles. What they have asked is for number of moles. What you have to do, so you just substitute the mole value here, 2.924 into 6.022 into 10 raised to 23. When you substitute that, you will get the number of moles, that is 1.76 into 10 raised to 24. So this much number of molecules will be present in 1 kilogram of sugar. So if they are asking the other way around, you are providing with number of molecules, this much molecules, and asking for the weight, what you have to do, you have to divide this with 1 mole number. This is with this number, so you will get this much mole is there, and we know the molar mass. If you multiply this with molar mass, you will get the mass, that is 1 kilogram. So you can be flexible with this. If one of the variable is given, you can use that. If two of the variables is given, you can use that to calculate the unknown variable in this equation. And also you can use the number of moles to calculate the number of molecules or atoms or number of particles in general to find out that number.